Helicopters are pretty well known for having high maintenance. I'm going to have to disagree on this helicycle. It so far just seems to be very easy to maintain, very minimal time on it. I've actually spent less time on this so far than any gyro I've ever flown. I say that because I have worked on pre-rotators more than I have on this whole thing here so far. I say so far because, hey, you know, knock on wood here, you know, it could be a nightmare someday down the road. If my luck is the same as the average helicycle guy, though, I will have very minimal time in this thing per flight hour. I'll just walk up here real slow here and show you some things to do. Every 5 hours up here on the rotor head, there are 11 grease circuits on the whole machine. And here's one, up here's one up on the teeter. Another one, a couple more on the other side. This rotor shaft support bearing's got one on it. We're just going to cruise on back to the tail here on the tail rotor. Our two zerks right there. Two little zerks right there. Again, these are every 5 hours. And then every part of my pre-flight, I'll put a drop of light machine oil here on this shaft here to keep that all lubed. And every 5 hours I'll shoot some oil here in this Teleflex cable. There's a little oil inspection window right here for the tail rotor gearbox oil. They say to change it every 25 hours. I've been, as little oil as this thing takes, I've just been pulling the plug and dropping it every 5 hours into a clear plastic cup, and then holding up to a light and looking for any filings or anything. So far it's been it was kind of real dirty at first as it was breaking in. It's typically normal, and right now it's just been staying a real nice golden color. So I think I pretty well got the tail rotor box broke in nice. And part of the pre-flight to check all the gaps here, all the bolts here. I've got torque seal on these, and I just kind of rock things around, check the carrier bearings. This whole drive shaft can come out of here in 10 minutes, and that would be taking your time. You just knock this brace loose, pull a bolt, take two carrier bolts off here on two bearings, and she just slides right out, and you just carefully slide it out so you don't scratch it. And then you can inspect, look at the bearings and stuff. Part of my annual, I'll do that. Another thing on pre-flight is to reach up the exhaust here, and what I'm doing is feeling the turbine wheel, and I'm moving it laterally this way, and then I'll turn it 90 degrees, do it again, 90 degrees, do it again until I turn it all 4 quadrants and check for any movement at all. You're not supposed to feel a bit, and that's just a routine check on that. Everything here I try to have spiral wrapped, no bare wires touching the frame anywheres. I've tried to safety tie everything off, and you just look for any loose things, oil leaks, fuel leaks, typical stuff, any cracks. This is my oil reservoir for the turbine. I've got a little safety wire on it just to take it off. That I check the oil level on that on pre-flight, and just look over all the belts and stuff, and I got torque seal on all kinds of bolts here. There's the grease circuit I was mentioning on that bearing. And you check your rods here for all movement. I get in the cab and move the cyclic and collective and check everything. And again, just look around for cracks. I've got these strengthening cables on my landing gear, and I'll check them for tension by the sound of them. No rocket science here, just typical pre-flight. And then you go in the cabin here, open the door, and grab the collective and I'll work it up and down and check for ease of motion. But while we're here, this is the collective friction here, so in flight I can tighten that up and go hands free if I want for a while. As I'm moving it, you can see the collective action here. You can see the pitch and the blades, each one getting the same amount. Next I'll move over to the cyclic here and I'll roll it around and all in one circle there. You can see all the movements. There's left, of course, right, forward, back. And of course you reach in here and you check your pedals and you just feel for any slop. Typical stuff. Now over here, this is a little worm drive. This is what engages the clutch. This little motor here pulls the front end of the turbine up or down. It's up right now for total looseness, and then when you put it in gear, this pulls this down, and these belts all tighten up. So you check your idler here. A lot of this stuff I do on a post flight. I'll check for looseness, and I'll put my fingers in there and feel the temperature, and I'll check the spray clutch here for freewheeling. Some of the maintenance on here, this is very minor. You pull these two bolts out and put another, like a skinny bolt in there, and put a little spring scale on here, and this thing is an over center deal, so that once the clutch is engaged, it goes over center and it locks itself in gear, so if something breaks here, it's not going to just go out of gear, it's locked in gear. You want to check the tension of this as it goes over center. There's a certain foot-pounds that you keep it set at. This is kind of a torque limiting device. I know some helicycle guys will actually tighten these more than they're supposed to, and that delivers more power from the turbine to here, and it's just you're just asking to put more horsepower into the transmission that BJ designed to take on 100 horse, and yeah, you could crank up this engine turbine here to 160 horse and tighten the belts fiddle string tight, and yeah, you could have your really hot machine here. Like it's not a good performer anyway, but you could really soup this thing up, and then you'd be tearing up the transmission in 100 hours probably. So not too smart. It's made to go 1,500 hours as is. That's plenty good for me. I never will fly it that long, or any other aircraft as far as that goes. So, and the rest of this is just back to the pitch links here, checking on this side, and I go through all the full range of motion on everything. Come back to here. This is the throttle control arm on the turbine. That's at flight idle at 45,000 RPM, and back to here is about 61,500 RPM, so it only moves about 3/8 of an inch. So this little actuator motor is what the governor controls to keep the RPMs right there where they should be. So far it's been doing a real nice job. This is the main fuel solenoid that I just switched out. It normally, on previous helicycle models, was a normally closed switch, meaning that with no power on, it closes the fuel off. Well, and then for normal operation, you have to have 12 volts sent to this to turn the solenoid on to turn the fuel on. That's all fine until you lose your power, and I've been wanting this changed out to a normally open main fuel solenoid, which I have just now done. The factory sent me out a reconfigured one, and now no matter what power failure, the fuel will not be shut off because of the power failure. I have a backup battery wired into the system with diodes to it will take charging from the system. It will also then run the computer should I have a total power failure, the batteries fall off, or a rat's on board eating my wires and shorting out things, and whatever you can think of. The diode protected little battery should run this governor and keep it all running for an hour. So, and I will know by my instruments up there that I've had catastrophic electrical failure and set her down. So, other than that, I'm trying to think what else outside of the, there's this is the new engine mounts here that I was the first one to have put on Group 5, and it's just a fantastically simple design and strong mechanism. It was so easy to install this turbine. I was all psyched up to be spending about 10 hours on it. I didn't know how long. It took me about 45 minutes to get the thing installed and aligned. It was really simple. So I just maintained the, watching everything. I still may put some more torque seal on a few other things here. I try to watch everything. On this exhaust pipe here. Yeah, I can wave to everybody there. On this exhaust pipe clamp here, you watch that. That's what holds this on. There's also kind of a redundancy here. This temperature probe here for the exhaust gas temperature gauge is bored through a hole there, so it wouldn't fall off. It would come loose and rattle before it would come out. And let's see, there's now you check for typical cracks, here anywhere's on the frame. And again, there's my cable support system. I'll kind of pan up it. I've got a little tape there in the intersection of it. I'm going to put some spiral wrap there. So somebody thought it might corrode, could sometime. Those are stainless steel cables. And you check here on your mixer. Here you move everything here and actuate it. This is where my fuel there. I take a sample out of that and drain any water. It's like a little gas escalator there, and works out real nice. I've got individual sumps here for low spots in my fuel tank. I just checked them the other day. I put like a quarter cup out of each one. I didn't see so much as a speck in it, but if I ever get any fuel, I could have quite a bit of water dumped in it, and at least a pint on each side, and before the fuel would, before it started going out into the tank here. So at the whole bottom corner of this, I'm trying to point to it here, right here could have water in it, and I'd be okay, and then I can drain it. And let's see what else. Check for battery mounts, see if they're loose. Check for cables cracking. I got dual batteries on here, and like I said, I could be flying along and I could have all my battery wires break off. I've also got a Key West regulator. I'll walk around and show you that. That if the batteries fail, I tried it out here on the ground. This little Key West regulator will keep the whole ship running. Lights, landing lights, radios, GPS, nav lights, everything. It'll keep it running. If that fails, the turbine will still run. I'll have all kinds of instruments that don't work, but my turbine will still be running, fully operational, and then I'll just set her down and fix the problem. Okay, I think that's about it. There's just it's just a very minimal maintenance. I'm looking up here. There's an oil filter on the other side of the turbine that I take off every 25 hours. Very minor. Other than what I've just told you, I clean this thing every once in a while, and when I clean it is when I really look everything over. I'm always scratching around, and if I see a little strip of oil or grease or something, I'll wipe it off thinking it's a crack or something, and that's how I keep a good eye on it. I plan to fly this thing a long time, and with a little bit of maintenance, and I don't think it'll be too much. I think I will. Okay, well, thanks for watching.